Welcome and thank you for joining our on-demand webinar for humidification systems for commercial printing. Today we will talk about different types of commercial printing applications and how humidification plays a very important role in the outcome for that printing facility and the quality of their product. At the very beginning, why humidify commercial printing? So having proper humidity levels is very important for printing in general, and we'll describe the different types of printing we're talking about in a couple of slides from now. But in all processes that require a good control, usually electrostatic discharge and mitigating that risk is one of the top items for most machinery. But also when we're working with hygroscopic materials, such as paper, having too much moisture or not enough moisture can be troublesome, and having good control can help alleviate those problems. Additionally, as we are working in these commercial printing facilities, there's a human aspect to this. We'll talk a little bit about how it's healthier to maintain humidification as one step of mitigation of viral, bacterial, and fungal proliferation events. And then lastly, having good humidity control can help printer function and increase its efficiency and effectiveness. So why this all matters? In this industry, there's probably about 25,000 companies in the US with a combined annual revenue of $81 billion. So this really helps the bottom line of making sure that high quality products being put out, and then that will help drive costs down as well as impact the final product price. So what are the issues in a little bit more detail around fluctuating or low relative humidity? The biggest one on the list is electrostatic discharge. And this occurs when dry air allows for static charge to occur, very similar to if you are rubbing your feet on carpet in a dry environment. You can then go zap someone in the room or touch something conductive and pass that charge. Now, when that happens with printing equipment, this can obviously cause misfeeds and problems with how effectively does it stack the items, how does it trim and fold the paper within that piece of machinery. While we're talking about most commercial printers, things are moving at a relatively fast speed mechanically. And precision is kind of the name of the game. And if you have any of those disruptions, that obviously can cause an impact to the product. So when these do occur, when electrostatic discharge does occur, this often increases the rate of rejection, and that increases your waste or the amount of material that you can then pass off and sell as your final product. So we want to make sure we obviously mitigate that risk and prevent static discharge transmission from occurring. It also, from a longevity perspective, ESD can cause damage to specific electronic equipment, which could prevent the equipment from running altogether. Some other issues regarding the paper moisture problems, and we're going to specifically talk as it relates to digital printing or printing that uses paper or cardboard or similar type of material to put an ink on and onto that material. So when we have that, when we have lower fluctuating relative humidity, the toner adhesion, how well that material sticks to, the ink sticks to that material, decreases. And we can have problems resulting in paper jams, for example, or smearing of that ink if you have bad adhesion. So in this specific industry, keeping the paper at a 50 to 55% relative humidity is optimal for this type of printing. Anything below 40% will cause that paper to evaporate the moisture that it contains, and it will start to change shape. Just like when you see, a piece of wood, for example, sitting out and moisture leaves its surface, it can curl. Same thing is true with paper itself. Another type of printing would be offset printing. So this is where that moisture content is equally as important as digital printing, but has different ranges. And this is how it really interacts between the ink and the press, and then the paper to the press and the ink to the paper, essentially, through that transference of ink material onto the paper material. So typically what we've noticed is keeping a higher moisture level of 55% or greater in the press hull is really what is observed in the industry. And if we get below that, again, curling is still really the biggest issue, followed by creasing and dot doubling. And then when the paper makes another pass through the printer, it can change shape again and then causing cracks along that folds once finished. So why humidify regarding healthy work environment? So the chart that's on the right side of this presentation is talking about a Sterling study that was done back and published, I believe, in the 1980s. And this is really showing what an optimal range is, looking at a couple different contamination sources, whether that's bacteria, viruses, etc. And when we talk back to the health and safety of our workers in this printing space that are running these digital printers making these products, we're impacted by that as well as materials. You could gain mold on materials. But really that optimal range, specifically for the human occupancy perspective, is between 40 and 60% RH. So what has been shown through studies is after you go below 40% RH, absenteeism actually occurs more frequently due to respiratory illness. If we look at this, outside of the numbers shown on this chart, think about winter conditions and how colds are more likely, and essentially that seasonality of humidity dropping in at least North American climates. With that study, the one piece of data that's important is if we have proper humidification, we can reduce absenteeism as much as 18%. Moving to thermal comfort. So there's another aspect to the human piece of this. Is thermal comfort is equally as important as how satisfied you are sitting in that space. I know myself personally, when it's out, summertime, it's 100 degrees and it's like 80% relative humidity. It's very uncomfortable. You're perspirating and it can be quite uncomfortable for yourself or other people in there. So if we can keep that in mind and condition that air specifically for people, that's obviously an aspect of temperature, but also humidity, where we talk about, in the winter where colder temps feel warmer as that humidity is higher. And likewise in the summer when that humidity is lower and it's high temps, it feels better on you. You're able to dissipate heat. So with that, most room temps, 68 to 72 degrees Fahrenheit. And back to that 40 to 60 can really impact the thermal comfort. Some other inefficiencies by lower fluctuating humidity. So inefficient printer function. So directly, humidity has that direct relationship to contribute to less downtime. Paper jams are a big thing that we talked about already, speaking about humidity, but also the paper sticking together, as well as if this process has any sort of adhesive properties that may activate based on certain humidity conditions. So something that we want to promote and be cognizant of is having a well-balanced area in that printing environment to give a consistent level of quality. And really the end goal for a printing facility, reduce waste, improve quality, and have longer life cycle of cylinders and plates depending on the printing type. So on the screen, based on ASHRAE conditions, this was pulled from the ASHRAE handbook, anywhere from plate making, with relative humidity of 75% RH, with a tight tolerance of plus or minus 2%. Lithographic press rooms, 43 to 47%. Rotogravure printing is 45 to 50. And binderies, where we're binding books, for example, 40 to 50% RH. The one thing that I want to talk about specifically is not the set point necessarily, but if we look at these charts and how tight of tolerance that is, and when we get into products, understanding what product might be a good fit for your specific application is very important. How well can you maintain that space? And there's many competing factors, opening shipping doors or windows or fans, etc. And humidity is just one part of that, but how can we properly maintain that? So the first thing, talking about a little bit about product, is understanding what energy source you have available at that facility. If you have boiler steam, you can choose to use it, you can choose not to use it, obviously, but it gives more options than, let's say, if you didn't. So if you did have boiler steam, you could potentially use a steam-to-steam heat exchanger or a dry steam STS unit. This will help provide pure steam into the space in case that boiler has steam line treatment to prevent corrosion and other things in that system, but providing clean steam to that space so you're not adding anything else into the air. Moving down the line of that left picture is natural gas. Is that available? As we talk about energy efficiency and energy cost, gas would be more cost effective currently in North America than electric when we talk about isothermal generators, just based on cost of good. So if that's true, does gas-fired work? And if you have a situation that has a low turn down, that might also help you choose potentially an electric humidifier or resistive unit if we're looking for high turn down. So there's something that to be cognizant of is to understand what your goals are, what you're trying to achieve, what are your energy sources. And then lastly, on the isothermal side is electric humidifiers. That could be resistive units or an electrode style that's passing current between the electrodes to generate boiling water. On the right side of this, essentially the other side of the coin, is adiabatic solutions. And it's a solution that's using the energy already existing in the air. This tends to be more common, traditionally seen high pressure atomization with fan assist, and we'll dive a little bit deeper into that. But from a top level perspective, instead of boiling that water, we're utilizing energy that might already exist in that space, whether that's geographically based. Let's say southwest of the United States would be one geographic location that has warm, dry air, or if your printing devices give off heat energy based on how they function. So the two options there would be high pressure atomization through dry steam or wetted media systems. Diving a little bit deeper into pictures of what that means from that tree. So obviously starting on the left, we have a steam boiler and pressurized steam. In the middle of that, the set of photos on the left is an electric resistive unit. On the right side is that electric canister style. That's an electrode style humidifier using electricity as a source. The bottom left is a gas to steam unit, GTS LX specifically. And then the bottom right is an STS system where we're converting that pressurized steam into clean steam. On the right side of this photo, showing pictures of high pressure atomization using a pump to spray through nozzles that are controlled by orifices. And then on the right, wetted media systems. Diving a little deeper into electrode style. So this would be a great choice for a single room humidifier. It can easily mount on a wall and disperse steam into that room, such as a bindery, where there might be a smaller load. We haven't really talked about loads yet, and we have an application example, but working through DryCalc software can help you determine what load you need based on a specific application. And this is something that can help you size appropriately that piece of equipment and go through selection. But this one is an electric source, smaller capacities than, let's say, a large gas to steam unit. But really the advantage of this electrode series is it's easy to maintain. There's no cleaning of tanks. There's no scraping away or using chemical cleaners to remove potential scale. This is as simple as replacing that canister as prompted by the controller display. With this advantage of combined space distribution unit, it can fit into a small, compact space and have minimal steam absorption distance. Going into the gas-fired humidifiers into the GTS LX series, It is the only one on the market that combines the high efficiency aspect to the ultra low NOx in a single design. This has been beneficial for many of our customers regarding having both of those standards and having it certified. What this does for the high efficiency piece and condensing design is allows for PVC venting, which can be a great cost savings compared to running materials that are better suited for high temps, such as galvanized or iron-based piping. Within this, there is a smart drain technology that allows different intervals based on the water quality. So you can utilize as much of that water as you possibly can based on what is coming into that tank to begin with. So it can go with anything from potable water, well water, softened water, reverse osmosis, or DI water. And the modulating output is a minimum of 5:1 for accurate humidity control. This also comes with outdoor-indoor models for flexibility based on your facility footprint. Dry steam's high pressure systems are in that adiabatic category, something that we've seen frequently in this space because of that printer technology and it giving off heat regardless of the geographic location. But with this, we can control multiple zones with a single pump station, allowing for a relationship of dispersion to generator or pump that is greater ratio than isothermal systems that are 1:1. The nice thing about this offering for in-space design is that fan assist offering, and that's something that helps provide like a hub and radial design for dispersing that air and moving that air to the water for better stratification control of humidity. We're pulling the air down from the top where it's the warmest and running it across a baffle plate and then evaporating the water. The other great feature, low energy use to run this, it's a single horsepower pump along with energy for the fans and controls. It does require reverse osmosis water or better. And lastly, it is a lower maintenance technology as it's fed RO water and it's water lubricated, so 8,000 hours between maintenance checks, etc. So dry steam's water treatment system, this is something that can feed our generators, or in some instances, reverse osmosis permeate has been fed as a dilution stream based on different printing technologies requirements based on their machinery. So within this space, we tend to soften that water to prevent scaling formation on the membranes. And as we work left to right, the RO system is removing 98% of the total dissolved solids from the supply water, whether that's feeding the high pressure system, whether that's feeding a piece of on-site equipment, or if that's feeding an isothermal generator such as a GTS-LX. Moving on to an application example, looking specifically at adiabatic. Looking at a print shop in Phoenix, Arizona, we see the outdoor conditions there. We need to get up to 70 degrees Fahrenheit and 45% RH, and two sections at 10,000 and 15,000 square feet. 20-foot ceilings. We didn't talk about this, but as you go through dry calc selection, there are different nozzle sizes based on the absorption distance. And the more space you have, the larger size nozzle you can use. Specifically on this application, 4 air changes per hour as well. So looking at HVAC layout, they have gas heaters for those design days that are lower than the set point temperature. And then they have large ceiling fans. Other than that, there's no mechanical ventilation system. So looking at product selection, we could do this a couple of different ways. And we kind of set this up for adiabatic specifically because we could benefit from cooling. But if we were to evaluate an isothermal humidifier, we could look at gas or electric humidifiers with space distribution units. With that, there is a limited capacity for those SDUs for gas or electric humidifiers. High pressure atomization, since this is a 2-zone system, we can do this with one single pump station and one water treatment. In this specific example, it's the best choice because it can handle that larger load and have a low energy consumption is one of the example goals of this specific application. So looking at this from a site chart perspective, in the winter, the downside is if we don't already have that existing heat in that area, you have to preheat. Some of this condition starting at the outdoor air could be preheated by existing equipment, or it could be by the gas heaters in that room as depicted. So to hit that target zone of 70 degrees Fahrenheit and 40% RH, we have to then overshoot that temperature to hit our goal target in winter conditions. So looking at that same application, but in summer conditions, what do we have coming in from temperature and what are we trying to target? So looking at this again from a site chart perspective, we can't do this alone with adiabatic cooling and evaporative cooling. That term, which would be, quote unquote, free cooling. We have to do this with mechanical cooling to achieve our final set point. If we're following an enthalpy line, we can't hit that alone. So mechanical cooling, but we can offset 13 degrees Fahrenheit of cooling, which equates to 39 tons of mechanical cooling, which can be very cost advantageous to do that. So why choose dry steam humidification systems? We're committed to quality. We've been designing and building world-class humidification for 50 years and added in water treatment to help service that as well. Support and reliability. Our dry steam technical support team is available to troubleshoot any issues and offer startup assistance and field service visits as desired. And lastly, case studies and research. We can support your business case with data. Dry steam is continually adding to our collection of white papers and case studies. We have one specifically on digital printing. If you go to our website to download that, it is drysteam.com, and talks a little bit about reducing the waste, specifically in printing applications. Thank you for your time today, and let us know if there's any questions.